Right now we're dealing with the climate impacts, and we just dealt with climate impacts from 0.8 degrees Celsius of warming. And now we're going to deal with where we are headed and what are the forecasts. Here is an outline of the temperature of carbon dioxide levels in the past 800,000 years. And the carbon dioxide levels have basically fluctuated between 180 and 180 and 280 parts per million for the last 800,000 years. Around 11,000 years ago in here, we started to basically have the emergence of farming, and we start to develop civilization as we know it. In 2008, excuse me, sorry about that. In 2008, we were way up close to 390. Presently, we're at 390 parts per million. And there's different scenarios. That is for lowering, if we lower emissions, a lower emission scenario would take us to 550 parts per million CO2, which is roughly 3 degrees Celsius. On our current path, which is what we're presently on, is the higher emission scenario, we're going to 900 parts per million. So this is where we've been for 800,000 years, and presently we're headed there. The prior slide is dealing with the Global Climate Change Impact Study that was published in 2009, and a recent article in the journal Science, I believe it is, argues that CO2 levels have not been this high, present CO2 levels. So we're at 390 parts per million carbon dioxide, and CO2 levels have not been this high for 15 million years. So the prior slide said 800,000 years, we know that from the ice core, and a new study is saying, showing that we haven't had CO2 levels this high for 15 million years. In 2009, there was an international agreement. This was supposed to be the time when we were really going to take serious action with regards to climate change. And the meeting in Copenhagen didn't turn out the way that many had hoped, including myself. In 2009, the Copenhagen Climate Accord, the United States, in the 2009 Copenhagen Climate Accord, the United States and more than 100 other countries agreed, a non-binding agreement, so it's not a legal agreement, to work toward holding global temperature increases to no more than 2 degrees Celsius over the pre-industrial period from 1850. So the goal is, and that's in line with the science, the goal is to hold to a 2 degrees Celsius increase over pre-industrial, basically since 1850. Right now, again, we've increased 0.8 degrees Celsius. Now, let me step back one second. I meant to explain this. If we go to 900 parts per million CO2, we are going to raise the global temperature 5 to 7 degrees Celsius. That's the estimate. Now I want to give you a sense of what these 5 to 7 degrees Celsius means. That does not seem like a lot of... Celsius is basically, to get the Fahrenheit increase, you multiply by 1.8. So a 5 degrees Celsius increase is roughly 9 degrees Fahrenheit. And that doesn't seem like a lot. We have temperature swings here in the Midwest of 30 degrees in a day. But that's weather. We're talking about climate, the average temperature over a long period of time and space. 5 degrees Celsius, back in the last ice age, 18,000 years ago, it was 5 degrees Celsius colder. And there were ice sheets in the northern latitudes of Canada that were 2 miles thick. And in Chicago, there were ice sheets over a mile thick. So a 5 degrees Celsius colder, we were in the midst of the last great ice age. So a 5 degrees Celsius warmer takes us to a very, very different planet. So while these seem like little numbers to us, their effect is enormous. So the Copenhagen Accord wants, the idea was that the nations agreed to a 2 degrees Celsius increase. And this is the boundary that scientists identify. And that boundary actually is coming down, as we'll see later in this lecture. That's a boundary we do not want to go beyond. But actually what's happened is the confirmed proposals from the Copenhagen Accord take us to 770 parts per million CO2. 770 parts per million. This is from the National Academy of Sciences. This is what that temperature increase would mean. 770 parts per million would fall in this category, 4 degrees Celsius of warming. There's a range that scientists estimate how much carbon dioxide would how much warming carbon dioxide would cause. Actually, the National Academy of Sciences is dealing with the CO2 equivalent, which is here. So the CO2 equivalent, that's a more technical thing I can't go into, is over 1,000 parts per million, and that takes us to a 5 degrees Celsius world, according to the National Academy of Sciences. So let's look at what a 4 degrees Celsius world would be. And here I'd like to draw on an image that Stefan Ramsdorff and people at the Potsdam Institute use from the Earth simulator, which used to be the largest supercomputer in the world. And this is what a 4 degrees Celsius increase would look like. And it begins in 1950. So we're just going to watch this for a minute and see what that looks like. As you go from, so the blue and the light blue is colder, black is no increase, and then as you get red to orange to yellow, so the yellow becomes 4 degrees Celsius increase, and then the white is up to 12 degrees Celsius increase. And so the globe doesn't, different parts of the globe will warm more than other parts, and we'll see this play out. So this begins in 1950, and we'll see it go all the way to nearly 2100. (1970). 1990, 2000, 2010, 2030, 2050, 2070, 2090, back up here a minute. Okay, and so we see in the northern latitudes, up in the Arctic, that's over 12 degrees Celsius increase. And then we have 4 degrees Celsius here. For most of the planet, the oceans are not as warm. But 2090, that is the grandchildren and great-grandchildren of students listening to this will be alive. And that is a different planet. And notice, the warming is greater up in the Arctic. It's called polar amplification. And this is a big problem, because that's where the Arctic sea ice is, that's where the permafrost is, That's where the Greenland ice sheet is up here. And so you're going to have greater warming there, and so greater ice melt. Now, the 4 degrees Celsius, the Earth simulator, showed that by 2096. But recent studies indicate that 4 degrees, that Richard Betts at the Hadley Center maintains that 4 degrees warming, if you take into account some of the fast feedbacks, we talked about the feedbacks of the Amazon trees dying, releasing carbon, creating more warming, creating more trees dying. These feedbacks, this vicious cycle. Richard Betts did a model showing that if we have fast feedbacks, we could see 4 degrees Celsius warming by 2070, and possibly 2060. Now, interestingly, to my knowledge, Betts did not, from my reading of his paper, did not include permafrost feedbacks in his model. So it might even be worse than what Betts thinks. It's possibly worse than what Betts thinks. So the permafrost, as I mentioned, I think 20% of Canada is permanently frozen ground. And what you have there is all the organic animals, plants are all frozen there. When that melts, microbes will decompose that plant matter and release carbon dioxide. In a low, in wetlands, for instance, in a low oxygen environment, they'll release methane. And methane on a 100-year time frame is 25 times more potent greenhouse gas than CO2, and carbon dioxide. Okay, and this feedback has never been put in any of the climate models. Recent studies suggest that if this carbon were released from the soils, it would increase, possibly increase, atmospheric CO2 levels by nearly 800 parts per million, which basically adds another 4 degrees Celsius warming. Studies suggest also that half the land-based permafrost would vanish by mid-century on our current emissions path. So half of the land-based permafrost would be gone on our current path by 2050. Students listening to this would be 60 years old. Their children would be probably 30, and their grandchildren would be probably like my children, under 10. Some put the number, possibility, that half that permafrost could be gone in a 2 degrees Celsius world. Or once you hit 2 degrees Celsius, if you leave it at 2 degrees Celsius, then you would melt half that permafrost. Releasing all this extra carbon, increasing warming, increasing further permafrost melt. This is one of the most serious, perhaps the most serious climate feedback, or positive feedback. A recent study just published last week indicated from the National Snow and Ice Data Center that this strong permafrost feedback is estimated to begin in the next 15 to 20 years, so between 2025 to 2030. So what all this indicates, if we take in, the models have not been able to adequately deal with the permafrost, so they don't include it, but we know that it's a big issue. And our recent studies are showing that this is coming quicker than we think, and it's a really big problem. If we melt the permafrost, the game is over. Now we'll switch to the issue of sea level rise. We saw this in a previous study that I just mentioned. Carbon dioxide levels have not been this high for 15 million years. This is the study from the journal Science. Carbon dioxide levels have not been this high for 15 million years, when it was 5 to 10 degrees Fahrenheit warmer, and seas were 75 to 120 feet higher. So we're already in a very serious levels of carbon dioxide in the atmosphere. Jim Hansen at NASA, I mentioned him, one of the leading climate scientists in the past 30 years, and Hansen has been ahead of the curve on many issues. Hansen maintains that 34 million years ago, says if you look at the Earth's history, 34 million years ago, Antarctica became cold enough to harbor a large ice sheet. And carbon dioxide levels were at 450 parts per million. Hansen estimated that there was an uncertainty of 100 parts per million with regards to the geological record. Present observations, according to Hansen and his team, reduced this level of uncertainty, allowing them to propose that 350 parts per million was the upper limit of carbon dioxide levels. If the end of summer Arctic sea ice was declining so quickly, and Greenland and West Antarctica were each losing mass more than 100 cubic kilometers per year, then clearly, according to Hansen and his group, the ice sheets are unstable with the present climate forcing of 385 parts per million. That was a few years ago, this study, I believe 2007. So for Hansen, if we stay at our present levels, we're in big trouble. And Hansen says this in his recent book, his book of 2009. If humanity burns most of the fossil fuels, doubling or tripling the pre-industrial carbon dioxide level, so if we go to 560 parts per million or 840 parts per million, tripling, Earth will surely head toward the ice-free condition, with sea levels 75 meters or 250 feet higher than today. Now, when Jim Hansen says surely or certainly, it makes me nervous. He's been right, and he's used very strong language about levels of certitude previously for many years, and he's been right. Now, you do not wake up one day and all of a sudden sea levels are 250 feet higher. That takes hundreds, if not thousands of years. But Hansen asked this question. The delay, so the delay also, so it's a devastating, an unimaginably devastating effect to have 250-foot sea level rise, but the delay, the time it takes, has its own devastating component. And Hansen summarizes this nicely. What would it mean for our globalized society if there were no stable coastlines for centuries? Sea levels rose for centuries. No stable coastlines. What would it mean for civilization if the sea level rose 3 feet every 20 to 25 years? So 12 to 15 feet a century, for centuries, as it did at the end of the last ice age, 14,000 years ago. So Hansen has been saying that if you look at the Earth's history, that ice sheets can melt very quickly, raising sea levels 12 to 15 feet a century, as they did 14,000 years ago. So that's the long-term look at sea level. Now we look at sea level rise this century. Stefan Ramstorff and Martin Vermeer have argued that sea level, an upper limit would be 2 meters, a little over 2 meters, so roughly 6.5 feet sea levels could rise in this century. Jim Hansen, in an article, suggested that scientists were being too reticent, they were being too cautious, and that if you looked, as I mentioned, at the Earth's history, he maintained that the sea level could rise 15 feet in a century. And here I'd like to give a sense, with this video, I'd like to give a sense of what 1 meter sea level rise would mean, so we can put this in some context. Remember, the U.S. is a coastal nation with 12,000 miles of coastline and 53% of all Americans living in and around coastal cities and towns. So it's important for us to recognize, what does this mean? So now we're going to look at what a 1 meter sea level rise amounts to.
We've taken a look at very, very fine data and got all the way down to a meter and less than a meter to see what would happen along our coastline. We have looked at over 100 locations, that's hundreds of cities and towns, because each location might have a few cities and towns in it. I'm going to take you down just a few to see what would happen in the U.S. with just a meter. We're not talking about Bangladesh, we're talking about the U.S. Let's start up in Point Pleasant, New Jersey. That's just 1 meter of sea level rise. In fact, almost every location along the coast of New Jersey is affected like that. This is Elizabeth City, North Carolina. That's a meter, that's a meter and a half, and then at 2 meters, the whole place is gone. Go down to Charleston, South Carolina, one of our most beautiful cities. That's a meter of sea level rise, and at a meter and a half. It wouldn't survive a meter, basically. We go down to Hollywood, Florida. That's just a meter of sea level rise. Those are houses in there, and churches, and community centers, and government buildings. This is Miami Beach, Florida. Miami Beach is on a porous underrise, so wherever sea level is, that's where, when you dig down, that's where the level of water is. This is just 1 meter of sea level rise. It wouldn't survive. Go over to Tampa, Florida. The downtown area would be inundated with 1.5 meters of sea level rise. New Orleans, the whole southern part of Louisiana is pretty much gone with 1 meter of sea level rise. Up the West Coast, the Bay Area is hit pretty hard. This is Silicon Valley, Foster City, the San Mateo area. That's just 1 meter of sea level rise.
So that gives us an idea. So the range between scientists is an upper limit 2 to 5 meters, so 6.5 to 15 feet this century. And we see what 3 feet in that video, in that clip, we see what a 3-foot sea level rise will do. But that doesn't even tell the whole story. So far we've just looked at sea level rise. You also have to calculate into the equation storm surges. And then it puts a 3 feet sea level rise into perspective. Let's take the example of New York City. When the sea rises 3 feet, a 1 in 100-year storm surge in New York City would occur every 4 years with billions of dollars of damage. Okay, so you have a 1 in 100-year storm surge right now. Happens 1 every 100 years. It floods lower Manhattan, causes great damage, but you rebuild it. It's worth, it happens statistically 1 in 100 years. With a 3-foot sea level rise, that same storm surge would happen statistically every 4 years. So what do? You don't rebuild. You abandon it. Other major U.S. cities would be severely impacted by 3-foot sea level rise, including Newark, New Orleans, Boston, Washington, Philadelphia, Tampa, St. Petersburg, and San Francisco. The whole coastline would be affected. Okay, so now we're shifting from sea level rise. Sea level rise won't happen immediately. You could have a big sea level rise this century. But what we will feel very shortly are severe heat waves. So on our current path, we're forecasted to reach 2 degrees Celsius by 2039. The students who are watching this lecture would be younger than I am in 2039. A study out of Stanford and University shows that even if we meet this goal, the 2 degrees goal, the United States is committed to more extreme heat waves. We're going to experience a marked increase in extreme heat waves. Temperatures equaling the hottest season on record from 1950 to 1999. This is from a study by Noah Diffenbaugh at Stanford. So temperatures equaling the hottest season on record from 1951 to 1999 could occur 4 times between now and 2019. So the hottest years on record, from 1951 to 1999, you could have those heat waves 4 times in the next decade. From 2030 to 2039, you would have the Southwest, Utah, Colorado, Arizona, and New Mexico, can endure at least 7 seasons equally as intense as the hottest season ever recorded between 1951 and 1999. The study concludes, quote, "The possibility that intensification of hot extremes could result from relatively small increases in greenhouse gas concentrations suggests that constraining global warming to 2 degrees Celsius may not be sufficient to avoid dangerous climate change." So the author is showing that this is going to happen if we, on our current emissions path, by 2039, these extreme events. So we see the events per decade increasing. The red, orange, and moving to purple, those are more extreme events. Happen more often per decade. So we'll have extreme heat. There's also severe droughts that would come from that heat. The maps that I'm going to present are based upon, in the next slide, are based on the Palmer Drought Severity Index. The positive numbers are for conditions that are unusually wet for a particular region, and the negative numbers when conditions are usually dry. A reading of -4 or below is considered extreme drought. Regions that are purple or green will likely be at lower risk of drought, while those in the red and purple spectrum could face more unusually extreme drought conditions. And in the Dust Bowl, the Great Dust Bowl in the United States, the Palmer Drought Index was basically rarely exceeded -3, and occasionally spiked to -6. So let's look at this. So this is 2030 to 2039. Again, students, you will be younger than I am, you'll be younger than 40. And on this index we see, okay, -3, orange. That is basically what was going on during the Dust Bowl. And we see over here the purple, that would be greater than the Dust Bowl, than what was most often in the Dust Bowl period, so that's -4. And -6, predominantly the Southwest is -6. So it never, rarely spiked to -6 on this index during the Dust Bowl of the 1930s. This is 2060 to 2069. Here, now you're in -10. Here in the west, Midwest region, you're at -10 and -15 on the index. So way outside whatever you had during the Dust Bowl. And then in 2090, 2099, we can see that you're -15 on the drought index in this area here, and -10 here, but we can see massive drought, -20 down through Mexico. The author of the study maintained, quote, "We are facing the possibility of widespread drought in the coming decades, but this is yet to be fully recognized by both the public and the climate change research community. If the projections in this study come even close to being realized, the consequences for society worldwide will be enormous. Drought will probably be the most serious and the soonest problem and the most serious problem because it affects water and food. a study, this is a very important study, because carbon dioxide lasts so long in the atmosphere. I indicated that 25% of the CO2 we put in the atmosphere today lasts 1,000 years, and 10% will last up to 100,000 years. This study by Susan Solomon, a distinguished figure at NOAA, maintained that at 2 degrees Celsius, from 2 degrees Celsius to about 3.5 degrees Celsius, you would have an irreversible drought. So from 2 to 4 degrees Celsius over the coming century, the effects are irreversible dry season rainfall reductions in several regions comparable to those of the Dust Bowl era, and inexorable sea level rise. Permanent dust bowls in the U.S. Southwest, Southern Europe, Northern Africa, Southern Africa, and Western Australia. So it's irreversible. That's 2039 and beyond. Just imagine the economic and social consequences of turning the American Southwest, Southern Europe, Northern Africa, Southern Africa, and Western Australia into dust bowls for at least 1,000 years. Here are some images from the 1930s Dust Bowl in the Midwest. Interesting to note that hundreds of thousands of people left. 85% of the population of Oklahoma left Oklahoma during the Dust Bowl. So you're going to have migration issues. You're going to have migration issues from sea level rise. People are going to be moving. And you will have Dust Bowl, from the Dust Bowl people will move. And remember, we saw and we talked about the issue of Darfur. Darfur was created by people migrating from drought. That's how the war started. And you'll have lots of migration. An enormously serious national security, international security issue. Climate change also affects global food security. A study conducted in the Philippines by the International Rice Research Institute maintained that for every 1 degree Celsius rise above the norm, wheat, rice, and corn yields fall by 10%. Here is an important study, and this study was taken up by the National Academy of Sciences in its recent review of the literature, and it had an important place in that. The study maintains that the United States provides 41% of the world's corn and 38% of the world's soybeans. These crops comprise 2 of the 4 largest sources of caloric energy produced and are thus critical for world food supply. So we produce 40% corn and nearly 40% of the soy. The study dealt with what happens to corn and soy yields and cotton yields with increased warming. The study maintained that if we stabilize CO2 at 3 degrees Celsius, roughly 3 degrees Celsius, corn and soy yields are predicted to decrease by 30 to 46% before the end of the century. On our present path, the high emissions path, corn and soy yields are predicted to decrease by 63 to 82%. The National Academy of Sciences maintain that for every 1 degree Celsius of warming, corn yields will drop 11%. This would be obviously devastating for this state, Nebraska, but it would have enormous impacts on global food security. And the problem gets worse because of the population issues. By 2030, the population is likely to increase from a little over 6 billion today to 8 billion. And more people in the developing world are moving from simple diets, grain diets, to complex diets which involve raising cattle, which are grain intensive. Because of this, the demand for food by 2030 is predicted to increase by 50%. So a 50% increase by 2030 in food demand. So we not only have a food security problem, we also have a water security problem with climate change. Half of the world's 6.7 billion people depend on rivers, whose fresh water source is mountain glaciers. 70% of our freshwater resources are used for irrigation of crops. So if you're going to have water problems, freshwater problems, that's also going to affect your food problems. A study in the Journal of the Preceding National Academy of Sciences, Jim Hansen was an author on this, maintained, quote, "The Tibetan glaciers have been melting at an accelerating, alarming rate over the past decade, raising the threat that many of the glaciers could be gone by mid-century," end quote. This would create water problems for 1.3 billion people. See, the glaciers act as a great water tower. During the winter, they collect snow, and during the summer, they release that, as they melt, they release that water. The snow is melted and release that water, and people use that for drinking and irrigation. So they act as an enormous natural water tower. And as these glaciers melt and diminish, then late in the summer months, you will have really bad water problems. There will not be enough water for people. That's happening in the Hindu Kush, Himalayan Tibetan Plateau, which some call the Earth's third pole because it has so much ice in the mountain glaciers. But it's also happening here in California, and will have severe consequences for California agriculture. At 3 degrees Celsius, this study from the Proceedings of the National Academy of Sciences estimates that the Sierra Nevada snowpack would reduce 30 to 70%, 3 degrees Celsius. At the high emission scenario, 5 degrees Celsius, snowpack declines would be 73 to 90%. So late in the growing season, you would have no water. And ultimately, you wipe out these glaciers, you might wipe out California agriculture. Secretary Stephen Chu, the Secretary of Energy, maintained in an interview that he said this. He said, Americans don't understand in their gut what we're talking about when we talk about climate change. We're talking about the loss of agriculture in California. He was referring to this study. So we'll have drought, we'll be losing our freshwater resources, and the wildfire threat in the U.S. will increase. The same study in the Proceedings of the National Academy of Sciences argues that at 3 degrees Celsius, California will lose 50 to 75% alpine and subalpine forests. Okay? Right now, we're heading to 5 degrees Celsius, and the Copenhagen Accord takes us to 4 to 5 degrees Celsius. California loses, on the high scenario, 5 degrees Celsius, California loses 75 to 90% of alpine and subalpine forest by the end of the century. In regards to the forests in the American West, Professor Tom Sweetman, one of the world's leading fire ecologists, maintained in an interview that he thought by the end of the century we would lose half the forests in the American West from wildfire on our current path. The next slide shows that for the map of changes regarding wildfire. For a 1 degree Celsius increase, it talks about the area of land burned. So a 1 degree Celsius increase in this area leads to a 505% increase in wildfires. That's from the National Academy of Sciences. So we turn from wildfires, and now we turn back to the oceans and deal with the problem of coral bleaching. So coral reefs bleaching from warming and stressed from ocean acidification. One of the great marine biologists in the world, J.E.N. Varon, published an article in Yale Environment 360, and the title of the article was, "Is the End in Sight for the World's Coral Reefs?" And let me just quote to you from the article. "When I started researching my book, A Reef in Time, The Great Barrier Reef from Beginning to End, published by Harvard in 2008. I knew that climate change was likely to have serious consequences for coral reefs, but the big picture that gradually emerged from my integration of these disparate disciplines left me shocked to the core. In a long period of deep personal anguish, I turned to specialists in many different fields of science to find anything that might suggest a fault in my own conclusions. But in this quest, I was depressingly unsuccessful. The bottom line remains. Science argues that coral reefs can indeed be utterly trashed in the lifetime of today's children. That certainty is what motivates me to spread this message as clearly and accurately as I can. What happens is that as the oceans warm, that warming bleaches the coral reefs, and the coral reefs can recover from the bleaching. But if those bleachings come if there's not time to recover, then they ultimately will not recover. And then you lose the coral reefs. Also, ocean acidification, that is, carbon dioxide is being absorbed by the oceans. And for a while we thought this is a great thing, what a great service. And then we discovered that this was acidifying, it was making the oceans more acidic. And this made it impossible, or it's making it nearly impossible for coral reefs to build their shells. Here's an image of the Great Barrier Reef off Heron Island. Here is an image of a healthy coral reef. Coral reefs are like the ocean's rainforest. They're rich, enormously rich in biodiversity. And here's what a reef looks like after a die-off from bleaching. So Barron is maintaining that in the lifetime of children today, the world's great reefs could be gone. The Great Barrier Reef, I believe, is 20 million years old, the largest living organism in the world. And this has enormous ramifications, again, returning to the issue of the food supply. Not only is this unimaginably devastating, but it also has enormous consequences for human beings. John Beddington, the chief scientific advisor in the UK, said this: "This has enormous ramifications, the destruction of coral reefs, for ocean ecosystems and for human beings, because, quote, coral reefs provide a significant protein supplies to about 1 billion people." So this becomes another food issue. And this is from Professor Uwe Goldberg, who's a very, very well distinguished expert on coral reefs. He says this: "It isn't just the coral reefs which are affected. A large part of the plankton in the Southern Ocean, the copelopods, are also affected. These drive ocean productivity and are at the base of the food web, which supports krill, whales, tuna, and our fisheries. They also play a vital role in removing carbon dioxide from the atmosphere, which could break down." So the ocean acidification also affects these particular types of plankton, which are at the base of the food web. And also, destroying plankton will also increase carbon dioxide levels, because plankton absorbs the carbon dioxide. Another vicious cycle. The rising sea levels will also affect food supply. Okay, we're focusing on the food supply issue. If the seas were to rise 3 feet, 50% of the rice fields in Bangladesh would be devastated by flooding. A 3-foot sea level would wipe out the rice harvest in the Mekong Delta, which produces more than half the rice in Vietnam. Vietnam is the world's second largest rice exporter. According to Lester Brown, quote, "The fate of the hundreds of millions who depend on their harvests in the rice-growing river deltas and floodplains of Asia is inextricably linked to the fate of these major ice sheets." End quote. Another impact. In 2007, the Intergovernmental Panel on Climate Change warned that at 4 degrees Celsius, model projections suggest significant extinctions. 40 to 70% of species assessed around the globe. So at 4 degrees Celsius, we run the risk of extinctions of 40 to 70% of species. And right now we're heading to 5 degrees Celsius. Now let me just tie some of these together. And I don't have time for the whole globe, but what happens to the United States? So we will have, along the coastline, sea level rise, all along the coastline. So, and the nation will be under siege in some way. All the flooding along the coastlines, all the way through here, wiping out probably most of New Orleans. New Orleans will be wiped out, much of Louisiana. We run into major crop failures in the Great Plains here. Major crop failures. We have terrible droughts, basically from Kansas all the way across. We have major droughts, Dust Bowl type droughts. We'll have greater precipitation events. As this dries out, we'll have greater precipitation events, more extreme storms in the Northeast. And also in the West, we'll be losing massive wildfires of the West. So we'll be devastating the country. Not to mention what will happen in the rest of the world and all the suffering that will go on in the rest of the world, and all the instability and insecurity and wars that will result from water shortages and food shortages. People don't just sit around and starve. They'll go out and raid before they'll starve. Now, in my own dealing with this issue, there's many times that I try to retreat into the idea that, well, some of this is based on climate models. And so I was hoping that the climate models would be overestimating the problem. The science really comes from 3 sources: present evidence, the Earth's history, and climate models. And so as I was dealing with these pretty unimaginable consequences, my hope was that the climate models would be overestimating the problem. But the problem is that they have underestimated the problem on many major issues. So there is, in some real way, no escaping the scientific evidence. We've underestimated the problem. We've underestimated the rate of sea ice melt. The rate of sea ice melt in the Arctic is 30 years ahead of the IPCC projections of 2007. We've underestimated the melting of the great ice sheets. The IPCC models in 2001 projected that Greenland and Antarctica would gain mass until 2100 and then begin to melt. By 2006, it was clear that they were already losing mass. We have underestimated sea level rise. Actual sea level rise is 80% greater than was predicted by the 2001 and 2007 IPCC reports. The estimates of the maximum sea level rise by 2100 are now more than 3 times the maximum sea level estimates of the 2007 IPCC report. We have underestimated the rate of ocean acidification. Carbon dioxide pollution is raising ocean acidity 10 to 20 times faster than previous models predicted. So we've been underestimating the problem. And there's also an elephant in the room with this whole issue. If we look at the geological record, and we've known this since quite clearly by 1993, if we look at the geological record, we recognize that abrupt climate change is the norm, not the exception. What is meant by abrupt climate change? Let me give you an example. When the Earth emerged from the last ice age, around 11,000 years ago, the world warmed by at least 5 degrees Celsius in 10 years. Now, most climate scientists do think that there will be lots of surprises as we increase atmospheric greenhouse gases. Most do not think that this century we will have an abrupt climate change. But notice, there's many people who say, well, there's lots of uncertainty regarding the climate change issue. And there is uncertainty. We do not know exactly how it's all going to play out. But that uncertainty can also be, some people take comfort in that, and I did for a while, until you look at the evidence. The evidence suggests that the uncertainty is actually reason for alarm. We've underestimated the problem, and in the background we know from U.S. history that the climate can change very abruptly in 10 years' time. So a summary statement, a good summary statement comes from Michael Oppenheimer at Princeton. A summary statement about climate impacts. The more we learn about the problem, the more severe the risk becomes, and the nearer it looms, end quote. We began these various lectures, with this quotation from Lonnie Thompson, the most famous glaciologist of the tropics in the world. And Thompson, I won't read the whole thing again, but it's a nice summary of where we've come from. That is, we began with this quotation from Thompson, and it was to show you, so far, how Thompson is quite serious, how this is not just being alarmist. While this is very alarming, the evidence points in this direction. Thompson says here in the middle, why then are climatologists speaking out about the dangers of global warming? The answer is that virtually all of us are now convinced that global warming poses a clear and present danger to civilization. He also says further down, rapid and potentially catastrophic changes in the near future are very possible. And what I've tried to show people here, and one reason that these lectures are quite lengthy, is that you have to see all the impacts together. Often we just get impacts on sea level rise. That's usually what's talked about when we talk about climate change. But when you see all the impacts together, sea level rise, ocean acidification, heat stress, drought, crop failures, water problems, destruction of the ocean food web, you begin to see that we will have food problems and water problems. The very conditions for life that have sustained our civilization are under siege. I'd like to finish this section on forecasted impact with the views of 3 directors of major climate research institutes around the world. The first one is Jim Hansen at NASA. Hansen's been, what many say, ahead of the curve. That is to say that he's been right, and he's been out in front of people. He's been right for 30 years. Here's Hansen's judgment of where we are. We are on the precipice of climate system tipping points beyond which there is no redemption. What Hansen's talking about is these feedbacks, that once we push the climate system a little bit more, if we push the climate system a little bit more, these feedbacks, these vicious cycles which will increase warming, lead to further warming, that these are going to kick in and it will all be out of our control. The second one is from Hans-Joachim Schnellenhuber, who's the director of the Potsdam Institute for Climate Research in Germany. At a major conference in March of 2009, Schnellenberger gave a plenary address, a major address, and argued that with a 5 degrees Celsius increase from pre-industrial temperatures, the planet could probably support only 1 billion people. Now that's to put that into context, the planet's population is projected to reach 9 billion by 2050. So this is an unimaginable possibility, even if Schnellenhuber's very, very wrong. Even if he's 90% wrong, that's nearly 1 billion people. So we're talking about unimaginable consequences. And remember, we're on a 5 to 7 degrees Celsius trajectory right now. And the Copenhagen Accord takes us anywhere from 3 to 5 degrees Celsius, most likely 4 or 5 degrees Celsius. So this is the path that we're on. The third director is Kevin Anderson from the Tyndall Center for Climate Research in England. And here is Anderson's statement in an interview by the Scotsman, paper out of Scotland. For humanity, it's a matter of life or death. We will not make all human beings extinct, as a few people with the right sort of resources may put themselves in the right parts of the world and survive. But I think it's extremely unlikely that we wouldn't have mass death at 4 degrees Celsius. If you got a population of 9 billion by 2050, and you hit 4 degrees Celsius, 5 degrees Celsius, or 6 degrees Celsius, you might have 500 million people surviving. Now, it's very important to remember that if the feedbacks are fast feedbacks, there's a possibility that we will be at 4 degrees Celsius by 2070. There's even a possibility by 2060. So students listening to this lecture would be entering their retirement, a 4 degrees Celsius world. Now imagine what that would be. Imagine if we all just remain silent, go about our lives, and don't do anything to address this problem. Imagine what it will be in our retirement, the young people. In retirement, you know that your children and your grandchildren will be entering a world of utter chaos. And people don't just sit around and starve. They will fight. We'll have wars all over the place. What would it be to know at the end of your life that what you've left, your children, what our generation has left, our children and grandchildren, is a world that will slowly devolve. That is, a world that will slowly spiral into chaos. So there would be no sense of progress. We all have a sense of progress about the future. Here, all you would have a sense is of the world becoming unraveled. And you would know that the ice sheets would be gone, so you would be going at 4 degrees Celsius. The ice sheets are eventually going to go. That means the loss of our great coasts. That means the loss of the capital in Washington, D.C., and all our great cities. It means wiping out much of the Great Plains food supply. It means drought and forest fires. It's an unimaginable world. But that's the world that we're headed on, with heading towards 4 degrees Celsius.